In this video, I'm going to do section 8.3. We're going to talk about section 8.3. This video will be a lot shorter than the other two. I just didn't feel comfortable adding it on to section 8.2. A little too long of a video. Since it is a little bit shorter, I do have somebody watching me.
Hi.
That is my daughter. Okay, again.
Hi.
So maybe I'll have her on video sometime so you guys can see her. All right, 8.3, we're estimating population proportions. So we're doing the same process as we did in the last section. The only thing different here is that we're working with proportions instead of means. So we're looking for a number of people in the sample that have a certain characteristic. With the characteristic, get that handwriting over there, and over the number in the sample. Remember from section 8.1, this notation, if we're looking for the population proportion, would be P. If we're talking the sample proportion, we're talking about P hat. So the same two things that we did in the last section we're going to do here. We're going to construct and interpret confidence intervals and then choose a sample size. The same basic foundation applies here with a confidence interval. So we're estimating our population proportion. We're going to put that between the sample value or the sample statistic, and then we're subtracting or adding a margin of error. And again, we can write that in interval notation as well, P hat minus E, P hat plus E. To calculate our margin of error in this scenario, we need the formula E is equal to 1.96 times the square root of P hat times 1 minus P hat over N. And then as always, we need to make sure to include that interpretation. If we're looking for the number or the number in the sample that we should choose, so choosing sample size, N is going to equal 1 over E squared. Let's erase this and work out numbers 8 and 9 from the problem. So we're going to move on and talk about Mendel's genetic experiments, because one of those experiments yielded 500 ADPs with 428 of them green and 152 of them yellow. We want to use the sample results to construct a 95% confidence interval for the estimate of the population proportion, and then we need that certain characteristic. Here we're talking about them being yellow. So we first need to determine our value of P hat. P hat is the number with that characteristic, so 152. So the number that we're yellow, and the total number in the sample here, which is 580. I usually recommend writing those as a decimal just to make the calculations a little bit easier in a calculator, but you're free to leave it as a fraction if you would like. I'm going to approximate this P hat to be 0.2621. And then I'm going to go ahead and start constructing my confidence interval by first determining my value of E. It's 1.96 times the square root of P hat. So here that's going to be that 0.2621 times 1 minus P hat. We're taking 1 minus that P hat value. We should have 0.7379 all over N, which is the 580. Remember, that would be our little n, so the number in the sample. Again, in your calculator, instead of doing this all at one time, I recommend segmenting it and showing as much work as possible, just in case we do a calculation mistake or the way that we put it into the calculator is incorrect. At least show me what formula we are using and the values that we have placed in for each variable. So I can give as much partial credit as possible. We should have E coming out to being approximately 0.0358. If you did not get that value, just go back and recalculate, see if we're coming out to be, coming out to get a value that's fairly close to that. I'm going to erase this just to make a little bit more room and write those values out so we can construct our confidence interval. We had P hat was 0.2621, and our margin of error was 0.0358. I now want to construct that interval. So I'm going to take P, because that's what we are looking for an estimate for. Then we take the P hat minus margin of error, P hat plus margin of error. We should have that interval 0.2263, and then a maximum interval value here of 0.2979. That is our confidence interval. But again, whether or not the problem states to do so, we have to include an interpretation. All right, sorry to pause for a second there. I had someone knock on my door. Social distancing. Let's continue with that interpretation. So with the interpretation of this 95% confidence interval, again, we want to make sure to state that with 95% confidence, we can say that the true, and then we need to know what it is we're talking about again. So here we're talking about the proportion. So we would say that the true population proportion of yellow, or of all yellow P is between the two values that we had in our confidence interval. So it's between 0.2263 and 0.2979. Most of the time we want to keep those proportion values as a decimal for easier calculation, but if you wanted to also write this as a percentage, we could say it's between 22.63% and 29.79%. Go ahead and clear this. I'll give you just a second to write that down if you're following along. Part B says, assume that we plan to conduct another genetics experiment to determine the proportion of peas that are green. I'm going to go ahead and circle green and circle proportion so I know what I'm working with here. How many sample peas would be needed in order to have 95% confidence that the margin of error is 0.04. So here we're going to, since we're looking for how many, we're calculating a sample size. N is equal to 1 over E squared. We have our E value of 0.04. Taking that value squared gives us 0.0016 in the denominator. And then 1 divided by that value gives us 625 P's. On number 9, it says identify what is wrong with this 95% confidence interval for a population proportion. And we're saying that P is between $250 and $500. So the main thing here to note is that these are given as values. And most of the time, actually, all of the time if we're talking about a population proportion here. If we're talking about a proportion, then the proportion should be not actual values. So we would need to have it actually expressed as a proportion. So either in the decimal to represent the proportion, the fraction to represent the proportion, or the percent to represent it. But we do not want to use just dollars here, giving a range. That's going to wrap up section 8.3 and chapter 8. I will be posting a review for you. We will have our scheduled test on Tuesday, so keep an eye out for that. And then as always, let me know if you have any questions.